Welcome to This Explainer. Today, we're going to unpack a pretty fascinating journey. We'll be exploring how what started as a seemingly simple flight deal bot basically evolved into a thrilling case study on autonomous intelligence infrastructure. We're diving into the OpsHub Global Airfare Intelligence System. And let me tell you, by the end of this, you're going to see automation and data in general in a completely new light. So, to kick things off, let me ask you something we've probably all pondered while booking a trip. Have you ever wondered if that brutal 7-hour layover is really truly worth saving $100? Or, say, if arriving late at night into a totally new city actually ends up costing you way more in specialized transportation and, let's be honest, stress? You see, for years, traditional airfare platforms have essentially conditioned our behavior. They've trained us to think inside a really narrow box. We enter an airport, we pick a destination, we compare a few numbers, and then we just wait for the price to drop. But that totally ignores the true operational trade-offs of travel. The project we're looking at today recognized a core truth. The real intelligence wasn't just in finding a cheap ticket. It was in understanding whether the deal was actually worth taking. Right beneath those traditional search engines lies this hidden layer of opportunity that most systems miss entirely. The OpsHub system, it was built to hunt for those specific hidden factors. It factored in positioning flights to hub cities. It looked at regional airport arbitrage, figuring out if flying into a nearby city is radically cheaper. It calculated timing inefficiencies and some seriously complex layover mathematics. Basically, this required the system to have context and judgment, much like a savvy, real-life human traveler. And this brilliantly illustrates where the rubber meets the road. To capture this hidden layer, the system needed a proving ground, and Colombia became the absolute perfect test environment. Launching out of Baltimore/Washington International, the primary targets were routes into Colombian cities like Bogota, Medellin, and Cali. But, and this is key, even during these early planning stages, the vision was so much bigger. The goal was never to just be limited to one country. The real vision was always global, modular expansion. Part 1. Crossing the Threshold, the VPS Deployment Phase. So, moving the code to a virtual private server, or VPS, followed this precise, now familiar rhythm. You clone the repository, initialize the virtual environment, install dependencies, configure your environment variables, run validation checks, and finally, deploy. Now, this sequence might look like a routine checklist on paper, but in reality, it is incredibly high stakes. Literally, one broken dependency or one malformed configuration can completely collapse the environment before it even goes live. The invisible backbone of making this deployment actually persist was a utility called systemd. Most travelers would never, ever know it existed, but systemd quietly became the operational heartbeat of the entire Airfare intelligence engine. It granted the system persistent uptime, the ability to survive server reboots, and the power to operate continuously, all without depending on a human operator to just keep a laptop awake all night. Part 2. The Abyss Operational Chaos. Well, every system gets tested, right? The problem here started with incomplete environment variables. The keys responsible for authenticating the bot against Telegram's API were either missing or just improperly loaded. Normally, a service would just fail and stop. But because systemd was configured with a command to always restart on failure, those missing credentials sent the bot into a frantic, endless crash loop. The terminal just started screaming again and again and again. Literally every 10 seconds, the service relaunched itself. The logs rapidly filled up with endlessly stacking failed startup attempts. What was originally designed as this great resilience measure suddenly transformed into complete operational chaos. So the crucial point learned from this whole abyss was actually pretty simple. Automation without validation is dangerous. Now, the fix wasn't actually that complicated. They simply added pre-flight deployment checks to verify that essential keys, like the Telegram bot token, actually existed before the service was allowed to launch. It was a small adjustment, sure, but it marked a massive leap in maturity. The infrastructure literally started learning how to protect itself. But hey, the tests weren't over. Almost immediately after fixing that crash loop, another major issue surfaced during deployment. Sensitive bot tokens were briefly exposed inside terminal outputs. In a fast-moving deployment session, it's an easy mistake to make, but the implications? Terrifying. Anyone possessing that token could potentially gain total control of the bot. This scare forced the architecture to grow up incredibly fast. Security stopped being an afterthought. It became infrastructure. Environment files were permanently locked down. Tokens were rotated. Secrets were strictly isolated from the code repositories. operational hygiene wasn't just something tacked on later. It became baked right into the architecture itself.
Part 3. The transformation from alerts to briefings.
Now, the system needed to avoid overwhelming users with raw numbers and constant meaningless pings. Nobody wants that. So a really clever color-coded scoring framework emerged. Instead of treating every single price drop equally, the engine calculated relative opportunity strength. It applied urgency and emotional weighting to the deals. Yellow tier alerts meant, hey, there's a strong opportunity worth monitoring here. Red tier alerts, those represented aggressive, unusual pricing scenarios where you really needed to take immediate action. And honestly, this brilliantly illustrates the system's true evolution. It stopped just pushing random prices like, oh, flight price dropped. Instead, it started making deliberate operational arguments. It would tell you exactly how much you save by positioning through Atlanta compared to a direct route. The system essentially transformed from a bot just pushing alerts into a full-blown intelligence system delivering tailored briefings. Part 4. The ultimate boon. The autonomous ecosystem. As it turned out, the modular architecture proved it wasn't strictly tied to Colombia at all. Region packs could be swapped out, APIs could be replaced. The framework was a totally scalable model capable of handling international handler systems. In fact, it was actively preparing for expansion into places like Mexico, Peru, Argentina, and Southeast Asia. Finally, after surviving the crash loops, the security breaches, and all that deployment validation, the terminal returned this tiny, quiet, almost anticlimactic message: active, running. But behind those two words was a massive operational ecosystem finally working together, silently, beneath the surface. It was no longer theoretical, guys. The ecosystem was alive. This single bot proved a massive architectural point. It operated on the philosophy of one bot, one purpose. Instead of building one giant, clunky platform, the OpsHub ecosystem proved that specialized autonomous systems, each solving one focused problem exceptionally well, could combine to form a massive, distributed intelligence network. It was actively transforming raw information into operational decision-making at absolute scale. Because the ultimate takeaway of this explainer is that this was never really about finding a cheap flight to Colombia. What we just looked at is a working blueprint for scalable, autonomous infrastructure. And that leaves us with a fascinating, highly provocative question. If this operational philosophy can completely transform how we analyze and automate travel, what industry will this distributed intelligence network disrupt next? Think about it. Thanks for joining me on this explainer, and keep questioning the systems around you.